A few weeks ago, I challenged myself to find a way to curve light. If you are seeing that, challenge accepted. Did I make it? Well, I tried. Let's start from the beginning. A curve is a set of points. None of them is at a straight line. Here's a little animation to understand it. Well, we can bend light easily, but can we bend light in infinite times so the straight lines of the points of bends become points? We can't, because we need an infinite number of mediums with different bending powers. And that's impossible, or is it? I got an idea, wait. Here's a cup of water. If you put sugar on it, now the bending power should change. But if we put sugar in water in different amounts, decreasing, that means we have different decreasing bending powers. You tell me we need an infinite number of these. Just wait a minute. Well, if we put a decent amount of sugar in the bottom of a big, huge cup, maybe, of water, and we let it for several days, what happens that the sugar melts through the water a bit by a bit, giving us the different decreasing amount of sugar. And that way we got a lot of layers. That is an infinite number. Let's go to the future to see the results. Hey, I'm going from the future, and this is the experiment. So, if the experiment was good, just should be like this. But it isn't, and it feels like there's nothing happening. I don't know what I'm missing, just... Hey, welcome back. How was the results? Was it good, was it bad? It doesn't matter. I found that it doesn't make an absolute curve. Why? Because the bending happens at the molecular level. So our eyes doesn't see any difference, does it? But if we want an absolute curve, we should have bends at the Planck length. Equals 1.6 times 10 to the power minus 35. Which we can't do in our experiment, because the atoms are a million times bigger than this, maybe more, I don't know. You know it? Comment below. Why Planck length? Because it is the smallest measurement we can measure in the physics, which we know right now, the universe. The second method is to have an absolute curved surface at the Planck length and make the light goes through it. That seems odd, doesn't it? And the absolute curve appears around big masses. That's true. It happens around any planet, sun, a black hole, and our Earth that we live in. You feel that? That's gravity because of the Earth, the mass of the Earth. Anyway, it curves the space-time tissue to an absolute curve at Planck length. That's to our advantage. You are lucky, my friend, because the light happens to go through the space-time tissue, and that means that it curves around it. That discovery is discovered by Einstein. I don't know when and where, but I know it is. So, because the light goes through the space-time tissue, when it curves, the light curves with it. There you have it. Light curved. Just like you, I felt like that until I had a tiny bit of a problem. To understand the problem, we should do the ribbon test. Let's draw a line on a normal paper, two-dimensional paper. If the line is straight, the ribbon won't have any problem. It will lay flat. But if the line isn't straight, the ribbon will have a weird shape with extra fabric. So straight means flat, and curved is extra fabric. That's it. Okay, let's play with the test. I'm gonna curve this paper to make a cone shape and search for straight lines. Well, I learned this from Vsauce. Like, check it out. A line from the bottom to the top seems straight, and yeah, it is. Maybe a circle around the cone? Nope. Extra fabric. Okay, let's start from here and let the ribbon go wherever it wants. Just stay flat. And that makes a straight, curvy looking line. I said straight, curvy looking because from our perspective it is a curving, but From the ribbon test, it says that it is straight. So this curvy looking shape is really straight to the native sleeves at that cone. What? And a straight line at a curved surface is called a geodesic. Back to our curving light example. I said when it curves, the light curves with it. But it is just a geodesic, because if you follow it with the ribbon, it just doesn't curve, it goes straight. See? That is the problem. Now, what do you think? Should I call this a success? I don't know. But I'll leave you with this. The best way to do a curve is to write this equation. Now, if you like us, just subscribe, because it means a lot.